Yeah, hello everybody, and welcome to this talk about lazy loading. Perhaps I can have a picture, please. Yeah, here is the picture with the lazy cat and lazy loading. This talk is about improving startup performance with lazy loading. And as mentioned, I am Manfred. I'm a trainer and consultant, and I'm focusing on Angular. And I'm also part of the Google Developer Expert program, which I'm very proud of course. From time to time, I'm writing. My last book is the book with the most ugly cover animal, and it is about AngularJS. And currently, we are rewriting this book for Angular 2. So there will be a version of it in the next month that covers Angular 2 and all the stuff around it. So, what are this talk about? First of all, I want to introduce lazy loading. I want to show you how you can leverage lazy loading to improve your startup performance. And then I will show you how to prevent lazy loading for users that are not allowed to use some specific modules, for instance. And then we will talk about preloading. Preloading is another aspect that allows you to speed up your application that has been already speeded up by the means of lazy loading. And then we will also talk about an issue that arises when you combine lazy loading with shared modules. And I will also provide a solution for this issue. But first things first, let's start with lazy loading in general. Here we see the typical structure of an Angular application. And this structure contains a root module that is called app module here. It contains several feature modules for all your use cases, and it contains a shared module. And normally, Angular would load all these modules at startup. So all these modules have to be downloaded when the application starts. And this is exactly where lazy loading comes in. Because when you are using lazy loading, you are just starting with some modules. At least you have to load the root module into your browser. And then on demand, you are just loading the other modules. Just when the user navigates to the specific navigation points, you have to load this or that or another model. To take use of lazy loading, you just have to create a route that is pointing with load children to the module you want to load lazily. So in this case, you don't point to some specific component, but you are pointing to the name of your module file with load children. And this string not only contains the name of your module file, it only contains the name of your module class. Both parts are separated by an hash. And of course, the lazily loaded module has roots of its own, and these roots are loaded or respected when the module is loaded. So in this very case, where we have the root bookings, the whole URL that points to this root is flights bookings. Just remember, the root flights will trigger the lazy loading. This is the root that contains the load children property. And then the second part of this is just booking as it is stated within this routing configuration. It is as easy as this. When you are using Webpack, you also have to use a specific loader. For this, I would really recommend the Angular 2 router loader. This Angular 2 router loader splits your bundle into several chunks that can be loaded once by means of lazy loading. So enough for the theory, let's have a look at a demonstration that shows how to use all this. I have prepared a simple application I'm using to show much aspects of Angular 2. And this application contains a very simple login form. You can just click at login to get you logged in. So this is what I'm calling login for very honest people. I have found out that when everything is harnessed, then the things are quite easier. And this is enough for this demonstration. So after we have logged in, we can move to book a flight, and there we can search for a flight, for instance, one that goes from Hamburg to Graz. Or we can also search for passengers, and here our username is suggested as an initial value. So please keep this in mind that the current username is suggested here. We will need this later. This application is just doing eager loading. That means the whole application is loaded at once in the browser when we are starting the application. When we are looking at the outputs of Webpack, we are also seeing that there is just one or two bundles. There is this vendor bundle that contains, of course, Angular and the other libraries, and there is the app bundle that contains the whole application code. And for this very reason, it wouldn't be possible to lazily load a module because everything of my code is put into this app bundle. So let's modify the application to leverage lazy loading. And for this, I'm switching to the source code. And here I will introduce a new route to my root routes, to the routes of my root module. The path is flight minus booking. And here I'm using load children, and load children just points with a string to the file that contains the module we want to lazily load. So the name is flight booking slash flight minus booking.module. Then there is this hash, and then we have to append our name, the name of the class, which is flight booking module. Okay. So that should be enough to get some lazy loading, but I will also alter the routes of the lazily loaded flight booking module. Let's switch into these routes here. Here I have the path flight booking, and I will change this path to an empty string. So this causes the router to directly load this route after the lazily loaded module has been activated. Okay, I have also used this loader, this Webpack loader. And when we are looking to our console, then we are seeing that lazy loading doesn't happen because I have forgotten a tiny aspect. So let's switch back and let's go to my app module. Here I am directly referencing the flight module, and because of this, of course, the flight module is eagerly loaded. So let's comment this out and try it again. Duff goes down, so let's cross fingers. Yeah, here we go. We got another bundle. We got a bundle with the name do.s. Webpack is just giving numbers to all those bundles. And do.s contains my flight booking module with all the stuff that is involved with flight booking. So let's try this out. I will log in here. I will switch to flight book a flight, and it seems to work, but there hasn't been a proof that this part has been lazily loaded. So for this reason, I will switch back to home, and I will open my network tab. And here we have, as mentioned, network, and let's say we are refreshing this. In this case, everything gets loaded, everything but not the file do.s. But when we are navigating to book a flight, yeah, then we see that the do.js is lazily loaded at the end. So I think that was quite easy, and I also think that can be a quick win to improve the performance of your application. Okay. There are also situations where you want to prevent a user from lazily loading a route. For instance, not every user has the right to use every part of the application, and in these cases it would be more usable when the user would be prevented from loading some specific models. And this is exactly where guards comes in. Guards are services, ordinary services, that can intercept the routing. And they can also prevent and requested action. For instance, they can prevent to load a module, they can also prevent to activate a component or to deactivate a component. And it turns out that there are several base types for guards. Base types we can implement, base types like can activate or can activate child or can deactivate, and there is can load. And as mentioned, with can load we can prevent the loading of a module by the means of lazy loading. So here is a very simple example for such a guard. This is just a class, a service class that implements canLoad, and canLoad gives us this canLoad method. This method takes the root in question, and this method can now decide on whether to load this module or not. And in this case, I'm saying, okay, everything is fine, we are friends, let's just load this module. As you are seeing here, the return value of canLoad is either a boolean or a promise of boolean or an observable of boolean. With the later two, you can postpone your decision. You can just return a promise and decide on this current aspect a bit later. So after you've created your guard, you have to configure the guard, and for this you have to register the guard with your routing configuration. It turns out that there is a property canLoad where you can put your guard into. But there is a very important aspect here. The thing that you are mentioning here isn't exactly the guard you are using. This is just a token. A token in the sense of dependency injection. And when you have had a look to dependency injection in Angular 2, then you know that you have to bind some implementation to a token. And this is exactly what happens here in the second part of this slide. I'm just binding my offload guard to the token that is the offload guard itself. And so this offload guard will be used at runtime. But please keep one thing in mind when you're doing this. This has nothing to do with security. Guards are not about security, they are about usability. Security happens always at the server side when it comes to single page applications that run in your browser, because of course your user has all the code and your user can manipulate all this code. Because of this is just about usability. You want the user to prevent from filling out a large form just to find out that he or she isn't allowed to submit this form. So let's also have a demonstration for this. For this, I'm switching back to my source code. And here in my source code, I have prepared, of course, a guard, my offload guard. And as you see here, this guard is quite simple. It just implements canLoad. It is decorated with injectable. It gets my auth service injected that tells the guard whether the user has been logged in or not. And there is also the router injected. And here, when it comes to canLoad, I'm just checking whether the user has been logged in. And when this is the case, I'm returning true. And in each other case, I'm just redirecting the user back to the home route. So let's activate this guard. I'm taking this offload guard and I'm switching to my app routes configuration. Here we go. And here I'm just abandoning canLoad, and canLoad gets this guard here. And as mentioned, this is just a token, and for this reason I also have to set up a provider for this token. So let's use the short form that binds offguard to offguard. Let's use Alt and Enter to get a nice import statement from WebStorms. Did this work? Did I get an import statement? Yeah. Seems good. Okay, so let's try to switch back. Oh, there was something that was red, but I think now it works. Everything is green. Green is our friend. So let's reload this application. Yeah, and now we are getting the information, we have seen it also before, that we are not allowed to use book a flight because we need to log in before. So you can't see it, but you perhaps can hear it. I'm not allowed to use this navigation point. So let's log in and then we can use book a flight. Awesome. Okay, so much for lazy loading and for preventing lazy loading. In addition to lazy loading, there is a drawback that comes into play. The application needs some seconds to lazily load your module on demand. So there can be a delay when the user clicks on some navigation item. And this is exactly where preloading helps us. Preloading allows us to load modules by the means of lazy loading after the start of the application. And so, when the module is actually needed, it is available immediately. So this is somehow a trade-off between the advantages and disadvantages of lazy loading. We are just using free CPU cycles to lazily load the module after the application started. And using preloading is also very, very simple. You just have to mention a preloading strategy. You can do this when you are setting up your router module for your root module. The router module for the root module. Nice. In this case, I'm using for root, and I'm passing my root configuration. You know, this array with all these route objects that are mapping some paths to some components. And in addition to that, you see it here, you can also pass an object with some settings, and as part of the settings, you can pass in a preloading strategy. The preload all module strategy is a baked-in strategy. It comes with Angular, and as the name implies, it preloads all modules after the start of the application. So let's try this out. Let's switch into our application. Let's go to the routes, and this is where I'm setting up the routes for my root module. And here I'm just passing in my options object, and there is my preloading strategy property, and here I'm passing in preload all modules. Okay, so I think that should be enough. What does Webpack say? Webpack doesn't complain, that is a good thing. Let's switch back to our application. So let's get rid of this URL parameter. And let's have a look into our network tab. So I'm reloading the application, and now we should see that first of all the application itself is loaded, and then with the upcoming free CPU cycles, the application preloads our bundle. So where is it? Who has seen my bundle? Pardon? There should be somewhere my do.js file. Who has it? Sorry? Oh, okay, yeah, that is of course true. But I don't think that... Yeah, that could be the reason, yeah. So I would say for the sake of simplicity, let's just deactivate this can load guards. That is a good information. So let's update this. Crossing fingers. Where is my module? Oh, yeah, there it was, yeah. Here it is. And we are seeing it is loaded quite late. So hopefully it is loaded at a point in time where the whole application has been loaded and started. Of course, there is no proof for this in this simple example. And as I'm a guy that wants to prove this stuff, I have created a own preloading strategy, that is performing a delay for some seconds before it is kicking in the preloading procedure. And as it turns out, preloading or creating own preloading strategies is very, very easy. It is just a matter of implementing the base type preloading strategy, and this base type comes with this preload function. Preload takes the root in question, and it also takes a function. And now you can decide within this method whether to load this very module, this very route by the means of preloading. And when you decide for yes, you just have to call your function here. And for doing so, I'm just creating an observable that has a delay of 7 seconds, and then I'm doing a flat map, and flat map is just executing this function. And in addition to that, flat map is returning the observable of this method here. Okay, this is my custom preloading strategy. Let's use this one. I'm copying this, and I'm switching to my app routes configuration. And here I will use this strategy. Okay, what does Webpack say? Webpack doesn't complain. That is, one more time, quite good. The application loads, and now we have to wait about 7 seconds. And if everything works, and I hope so, the do.js is showing up. Awesome. So I think this really proves that this application is doing preloading. Very nice. In addition to that, there are also plugins out there in the community, plugins that are using the CPU idle hook some browsers provide to just find some point in time where the CPU has nothing to do, and then this plugin is starting preloading. Nice. Okay, so much about preloading here. I have also prepared another preloading strategy, a more senseful one. This preloading strategy is just checking a custom property that is called preload. So perhaps you know it. When it comes to the router, you can put a custom data object to every route. And you can put custom properties into this data object. And I have decided to go with a custom preload property. And only when this preload property is truthy, I kick in the preloading procedure, and in all other cases, I'm just returning a dummy observable. So to make this work, of course, I have to switch back to my routes configuration. And here I have to create a new data property. And here I am putting into the property preload, so I'm setting it to true, which is the truthiest value. So let's retry this. What does Webpack say? Perhaps nothing. Perhaps it is already finished. So here we go. Where is my do.js? Who has seen it? Yeah, here it is. So preloading kicked in. Let's do the cross validation of this. Let's set this property to false. No, let's clear this. Reload. Here we go. Yeah, as you can see, you see nothing. You don't see the do.js file. Great. So I think that is a quite important aspect, the possibility to write custom preloading strategies, because it prevents you from preloading stuff your user isn't allowed to use or your user shouldn't use now. Okay, so much for this. Let's go on. Let's talk about an issue. And about a solution for this issue, let's talk about lazy loading and shared models. So it turns out that there is really an issue when you are combining both aspects, namely lazy loading as well as shared models. And for this, I've also prepared a tiny demonstration. So let's go into our application and let's reactivate. No, we don't need it. Let's just log in and let's go to book a flight. And when we move to search passengers, we don't see our username as a suggestion. So somehow we have damaged this part of the application. You have seen it at the start of this talk. This has already worked, but currently it doesn't work anymore. For some reason, my username isn't known here within this route, but as we see here, it is known outside within the root module. What is the reason behind this? The reason behind this has to deal with our current model structure. When we look at our model structure, we're seeing that both the app module as well as the lazily loaded flight module is including the shared module. And the shared module is just providing an auth service, that knows the current username. And as a matter of fact, a lazily loaded module has its own injector, and for this reason, it has its own dependency injection scope. And for this reason, the flight module gets its own auth service because it also includes the shared module. So in this case, we have two auth services. The first auth service knows my username. This is the auth service where I have logged in, and the second auth service doesn't. The good message about this is that everything that can't be found within the scope of the flight module is looked up in the scope above, in the global scope, in the scope of the application. So all we have to do is to get rid of this auth service within the flight module. In this case, the global auth service would be used by both, by the app module as well as by the lazily loaded flight module. And the solution for this is just to provide the shared module in two ways. First of all, we have to provide this shared module with providers, and then we have to provide it without providers. That sounds a bit ridiculous, of course, but as we will see afterwards, doing this is quite easy, and doing this is the official solution for this issue. It is somehow a pattern the Angular team gives us, a pattern the Angular team is using itself, and a pattern some third-party vendors uses. For instance, it is used in ng2 translate. Okay, what do we have to do when we want to use this pattern? We just have to provide a shared module without providers, without setting up services. In this case, I just made this clear by setting the providers array to an empty array. And then we have to extend this module by a method that is normally called forRoot. This method is intended for the root module, and this method is returning a module with providers object. This object is somehow just a record that binds some new providers to a pre-existing module. In this case, my shared module is extended by my providers that includes my auth service. So that is everything we have to do. And then we can use the version that forRoot creates for our root module, and we can use the shared module itself with all other modules. So let's have a look at a demonstration for this. For this, I'm switching into my source code, and here I will switch into my shared module that sets up a whole bunch of providers. And within these providers, we will find the off service, the provider for our off service. And here I'm using a very simple refactoring pattern. Perhaps you know this refactoring pattern. I think Martin Fowler forgets to write about this. This refactoring pattern is called Control X. So, and then I'm going down here. Yeah, for some reason Martin Fowler didn't describe it. Then here I'm creating a static method, and the static method is called forRoot. And the static method is just returning a module with providers. So, and here I am returning this new object. Come on, I don't need caps lock. This new object that points to an ng module. Ng module is here the shared module. And then we are pointing to some providers. And that's all. Now I have two versions of my module, one version with providers and one without providers. So let's take the shared module and let's switch back to our app module, which is of course the root module. And here I will include the shared module with shared module.forRoot. So I'm getting all the providers here. So what does Webpack say? Oh, there are some red letters, but I think this is some old issue. Now I'm getting only green letters. Green is good. And just let's reload this application. So I'm logging in. I'm switching to book a flight, and I'm switching to search for passenger. And oh, it works. We have our username back. Fine, so we have one and only one shared service for the whole application. Okay, let me sum up what we have seen in this presentation. We have seen a whole bunch of features of the newest router. For instance, we have seen that lazy loading modules is very easy when it comes to the new router. You just have to point with a property to the name of your module you want to lazily load. We have also seen that Webpack can be our friend. Webpack has this nice, nifty Webpack plugin, this loader, this Angular 2 router loader that is splitting up your bundle into several chunks, and every bundle can then be loaded lazily by the router. We have also seen that there is something like guards that you can use to prevent the user from lazy loading some module. We have also talked about that this isn't about security, because security only attacks happen at the server side when it comes to single page application, but this is about improving the usability. We have also seen that there are several preloading strategies you can write and use to preload your modules. And we have also seen that you have to provide your shared modules in two fashions. You have to provide them once with and once without the providers to get rid of this issue that arises when you are using shared modules together with lazy loading. And then there is a last point I've learned during the preparation of this talk. I've learned that there are a lot of lazy animals in the web when you are looking for the word lazy and when you are looking for photos that are related to the word lazy. Okay, so much for this presentation. Here you have my contact data. Of course, I will upload my stuff to my blog, and of course you can find all the stuff then there. You can then download the sample and the slides. Thanks you for coming and have a nice day. Thank you.